Okay, continuing with being able to graph standard form, okay, our ax plus by equals c. Last video we looked at being able to rearrange that solve for y so that we can get it into slope-intercept form, y equals mx plus b. But we want to look at the second option now. So this was the first option. We want to look at the second option now. We can find and graph the intercepts of the linear equation. Now, when we're talking about the intercepts, we're talking about the x-intercept and the y-intercept. Now, what's the x-intercept? Well, the x-intercept is the point where the line crosses the x-axis. That's why it's called the x-intercept. And written as a point, it would be x0. Okay, in other words, we're not going up and down on the y. We're crossing the x-axis, but we're not going up and down on the y. And you say, well, why would that be? Well, let's look at a graph here, okay? We're just going to take an arbitrary graph, try to draw it a little bit better. Okay, and some arbitrary line that goes through it. Okay, now the x-intercept would be right here because it crosses the x-axis. That would be the x-intercept where we cross the x-axis. For instance, maybe this is a positive 1 here. That would mean that our x-intercept would be 1. I'm crossing the x-axis at 1. However, am I going up and down on the y at that point? No, that's the point 1, 0. Okay, so your x-intercept will always be wherever it crosses on the x, and the y value would be 0. Okay, now similarly, the y-intercept, okay, the y-intercept is the point where we cross the y-axis, and we've dealt with this before in slope-intercept form. It's our b where we cross the y-axis, and that's always 0y. Okay, that's 0y. In other words, we're not going left and right on the x-axis. However, we are crossing at some y value on the y-axis. Okay, so looking at this here, this guy right here would be our y-intercept because it crosses the y-axis. Okay, it crosses the y-axis. Now again, maybe this guy is a positive 1, but it's a positive 1 on the y-axis. Okay, in this case, the point would be 0, 1 because I'm 0 on the x, but up 1 on up a positive 1 on the y-axis. Okay, so in that case, it would be 0, 1. But in our case, when we're talking about the y-intercept, x would be 0, y is wherever we cross. Okay, so that would represent our intercepts there. Okay, where we cross the x, where we cross the y. Now, if they flat out tell you the x and y intercept, in this example they do, then all we have to do is plot our points and draw the line that goes through our two intercepts there, okay? Through the x-intercept and the y-intercept. Because you only need 2 points to graph a line, okay? In this case, they tell us the x-intercept is a -3. In other words, looking at the x, I'm looking for -3 on the x-axis. Now, written as a point, this would be -3 because I'm out -3 on the x-axis, but I'm not going up, I'm not going down. That would be 0 for the y. Okay, so that matches what we graphed here. -3, 0 would be there. Okay, now my y-intercept, that would be 3. It's saying that I'm out at a +3 on the y-axis. So now I'm looking at the y-axis and I'm graphing at a +3 on the y-axis. Written as a point, I'm not going left or right on the x, but I'm going up a +3 on the y. So those guys represent my x and y intercept because I cross the x-axis at a -3 here, and I cross the y-axis at a +3 here. Okay, so then graphing the line that goes through them, this would be my line. Okay, similarly, if they give us that the x-intercept is a -1, that means I'm looking at the x-axis for a -1. That would be my first point. Written as a point, we're out at -1 on the x, but 0 on the y. We're not going up and down, and that matches what we graphed. Then on the y-axis, I'm looking for a y-intercept of a -2. So on the y-axis, I'm going to -2. And again, written as a point, we're not going left or right on the x, but we're going down a -2 on the y. Okay, so this would be the line that passes through our x and y intercept. Okay, now we only need 2 points to graph a line. So if we can determine what the x and y intercept are, in this example they told us what it is, but if we can determine what they are, then we can graph our line. And that's where this next step comes in, because we want to be able to do this for standard form. So it says notice, in number 7 here, notice that when we want to find the x-intercept, the y is 0. Okay, so when we had the x-intercept, the y was 0. Okay, also notice when we want to find the y-intercept, the x is 0. Okay, so when we had the y-intercept, the x was 0. Okay, just like those examples that we looked at before. Now, therefore, think about it in this way. We can plug in a 0 into the equation. We're talking about our standard form equation, okay? Into the equation for x if we want to find y, or plug in 0 for y when we want to find x, okay? Now, oftentimes you'll hear this called the cover-up method, but because I can't actually show my hand covering up each side, I might just kind of scribble it out. But here's the basic idea, okay? If we're looking for the x-intercept, y will be 0. If we're looking for the y-intercept, x will be 0. In other words, if I wanted to find let's start out with the x-intercept since that's the first one that we have written. If I wanted to find the x-intercept, I can plug in a 0 for y so that I would have a negative 5 times 0. Okay? Now, what's a negative 5 times 0? 0. So basically this all goes away. That's the cover-up part. So if I cover up the y, what am I left with? 2x equals a negative 10. In other words, I'm just kind of covering up this part of the equation and I'm only focusing on 2x equals a negative 10. Now I can solve for x. I can figure out what my x-intercept is going to be. Okay? Well, solving for this, we divide by 2 and we get x equals, what's a negative 10 divided by 2? Negative 5. So my x-intercept written as a point, maybe I'll just write it to the side here. My x-intercept is a negative 5, 0. Okay, so that's what my x-intercept is going to be there. Okay, now if I want to find the y-intercept, what has to be 0? Well, the x does, right? So instead of covering up the y, I need to cover up the x. So think about it this way. If I plug in a 0 for x, what's 2 times 0? 0. So basically all of that guy gets covered up and we're left with a negative 5y equals a negative 10. Well, I can solve that. This is multiplication. What do I have to do? Divide by a negative 5 when we get y equals, what's a negative and a negative make? Positive. So when I divide there, I get a positive, and 10 divided by 5 is 2. So my y-intercept would be 0, 2. Okay, so when I covered up the x, I got 0, 2. So now I have 2 points. I have my x-intercept and I have my y-intercept. I can plot those. So let's plot negative 5, 0. So I'm out at negative 5 on the x, up 0 on the y. Okay, so negative 5, 0, that's my x-intercept. Then my y-intercept is 0, 2. So I'm out nothing on the x, not going left, not going right, but I'm up 2 on the y. Now I have 2 points. I have enough information to graph my line. Okay? So I only need those 2 points to be able to graph this line. Now we can do the same thing on number 9. If I want to find the x-intercept, okay, the y has to be 0. Okay? So if I plug in a 0 for y, what's going to happen? Well, 5 times 0 is going to be 0. In other words, that guy gets covered up. So what I'm left with is 3x equals a negative 5. Now, dividing by 3, we get this guy. X equals a negative 5 over 3. Now, is that guy necessarily going to come out to be nice? No. So at this point, you might want to kind of get a calculator, divide that out, kind of see what that comes out to be. Okay? So I get approximately, I'm actually going to go back here. Approximately a negative 1.67. Okay, so I get that my x-intercept is approximately negative 1.670. Okay, now my y-intercept, going back here to find the y-intercept, the x has to be 0. So if I plug in a 0 for my x here, 3 times 0 is what? 0. So this guy gets covered up and I have 5y equals a negative 5. Well, solving for this guy, we have multiplication. What's the opposite? Divide by 5 from both sides, and we get y equals, what's a negative 5 divided by 5? Well, negative and a positive makes negative. 5 divided by 5, 1. So my y-intercept, trying to write it to the side here, would be 0, negative 1. I'll try to write that better. A little bit better. Okay, so my x-intercept is, there we go, negative 1.67, approximately 0. So trying to go out here, that's about 2/3 of the way. So negative 1 would be here. Then about 2/3 of the way might be about right there. So negative 1.67. Okay. Then my y-intercept is 0, negative 1 over here. 0, negative 1. So I'm out 0 on the x, not going left, not going right, but down negative 1 on the y. So this would be my 2 points, and this would be my line. Whoops, try that again. Not too much better, but a little bit better. This would be my line that passes through my x-intercept and my y-intercept. Okay, so this is another approach that we can take. It's called finding the intercepts, or the cover-up method. Cover up the x, find the y, cover up the y, find the x, and then plot your intercepts and graph your line.